Hello, algebra kids. So we are now going to jump into adding and subtracting rational expressions. So when you look at fractions and when you add and subtract fractions, you have to have the same number in the bottom, right? You cannot add a half and a third and get a sixth. You have to have the same denominator. So let's practice with a few of these where they actually give you the same denominator. And if you recall, when you do that, the bottom stays the same. Okay, I'm not going to put two of them down there. But the top you add together. So 2x plus 4x is 6x. And then we can simplify that further because we have we have 1x on top and 4 on the bottom. So yeah, we are subtracting, it's going to be 3, but where? Well, there's 3 more in the bottom, aren't there? So I have x to the third, and I've got the 6 on the top. And that's our answer. So again, the bottom is the same. I'm adding now. Okay, that's so totally different than multiplying. So I can combine these. The bottom stays that common denominator. The top I need to add. So when I add m squared plus 2m plus 3m plus 4, right off the bat, I want to look for like terms. Are there any other m squareds I can put together? See, up here they both were x terms, so I could put them together. But I don't have any other m to the seconds. So I'm just going to write it here. Are there any other m's? Yes. So 2m plus 3m is 5m. And are there any other whole numbers? No. So we're at that point now. And now it's back to the skills you've learned in the other sections, which is to try to break down and simplify this. And we see a trinomial, so we think, okay, or do we know numbers that add to give you 5, but multiply to give you 4? Yeah, that one's pretty simple, isn't it? 1 and 4. So we now end up with m plus 1 times m plus 4 all over m plus 4. Oh, good. Because remember, this has to stay together, just like this does and this does. But we do have one pair that we can cross off. So that is equal to m plus 1. Okay, again, another example where the bottom is the same. So we will go ahead and keep the bottom the same. We're going to put it together first, then we try to simplify. So when I look at the top, are there any other 3k's, or any other k's, I mean? Nope. Let's put 3k. Negative 18 plus 6, I can put those together. Those are whole numbers. So a negative 18 and a positive 6 is a negative 12. And now's where you actually start to simplify. So we're going to factor here, greatest common factor. So you can take out a 3, and when you divide a 3 out, you're left with k minus 4. And now this, who sees what that is? It's a difference of two perfect squares, k squared and 4 squared. So we can write them k plus 4 and k minus 4, which is lovely, right? Because you can see the k minus 4 can cancel, and we're left with 3 over k plus 4. All right, this one looks a little more complicated, but the bottom is still the same. So we are going to move forward now, keep the bottom the same. And notice the difference here. We're subtracting. That does add an extra element right here, because this subtraction sign has to be distributed to both, or any, if there's 5 things up here, it would have to be distributed to all of them. Okay, so I can rewrite this as a plus and make each of those a different sign. Okay, that's what you really need to remember. When you see a subtraction, change it to a plus, go ahead. But then you got to change on the top all the signs. So do I have any other y's? I do. I've got a minus y. So I've got a 6y minus y. Remember, it's a 1y. So that's 5y. Do I have any other wholes? I do. I have a negative 6 and a negative 4, which is a negative 10. And now we simplify. I see there's a common factor of 5. So I'm going to divide them both by 5, get y minus 2. And now let's check to see, is there something that adds to give you 4 and multiplies to give you 12? 3 and 4, no. 2 and 6. Oh, that might work. Will 2 and 6 work? I don't see the 2 and 6 working. Oh, it's a negative 12. Okay. I was like, I don't see how this is going to work at all. I'm like, I'm missing something. Yep, that's a negative 12. So then it works because I can make one of them negative here. All right, so that's gone. And now I have y minus 2 and y plus 6. And just for those of you that struggle a little bit with the factoring, maybe, just a hint is always when you see this on the top, it's right now probably pretty likely it'll be on the bottom. So you could kind of use a negative 2 as a guess. But I think you're mostly pretty good at it, so not too worried. Those cross off, and we are left with 5 over. Okay. And then we're going to move on to lowest common multiples. When you're finding the least common multiple, you're trying to think of a number that you can divide both of these by. So can anybody think of a number? Well, and you know what's a good way to do it too, rather than just trying to come up with it in your head? Take the biggest one and do multiples of it. So if you have 12 times 1 is 12. What's 12 times 2? 24, 36, and so on. And as you're doing that, you're trying to think, do any of them divide by 9? And the answer is yeah. So you kind of can take the biggest one and start listing them until you see one that works for the 9. That might be the shortest way to do that. So 36 is the number part of it. And then we want the least common multiple. So we want something that we can multiply both of them by and get. And so the way you'll get the variables here is take the highest variable power. So when you look at the two x's, which one has the highest power? This one. And when you look at the y's, what's the highest power? Of course, the 3. And that is the least common multiple. Okay? That means I can multiply this, let's see, by 3y squared, and I'll get this. I can multiply this by 4x, and I'll get this. So you're trying to find out what is that thing that you can multiply each of them by to get it, but it's the smallest one. Okay, so let's look at these. So they give you two trinomials here. Well, it's kind of the same now. So we need to do, okay, what plus what equals 8, what times what equals 15. Oh, 3 and 5 looks right. So we have c plus 3 and c plus 5. Because we're looking for, we need it to be multiplied. Like these are all multiplied up here. We need that here to be able to find the least common multiple. Multiply. First thing I'm going to do though is I see a greatest common factor of 3 here. So I'm going to take that out first. I divided them all by 3 to get that. Now I'm looking for two numbers that add to give me 6 and multiply to give me 9. 3 and 3. I leave the 3 out front. So now when we look at this, we need to include everything. Okay, so because we're least common multiple. So even though it says least, we're talking about multiple. So I need to include everything. So c plus 3's. Which one has more c plus 3's? This one. How many? 2. So that is part of my least common multiple. C plus 3 to the second. Okay, and I got to include everything here. So are there anything else that you see? C plus 5. Which one has more? This one. Then you take that value. Okay, anything else you see? Yes, the 3. That has to, I'll put that out front. So this is the least common multiple. And the reason we need to do this is because when we start to add now, these all had common denominators that we did. When we get to adding ones that don't have common denominators, you need to figure out these because that's going to be your new common denominator. Okay? So we'll take a look at that on the next slide here. All right. So when you are going to add these, see the bottoms aren't the same. So we need the least common multiple here. And I'd like you guys to help me figure that out. Okay, I got to include everything from both, the highest from both. So I have a 5 and a 2, and there's nothing that will divide. Well, let's put it this way. Let's do it the way I was saying before. I see some of you will see this, and you don't have to do it this way, but it's fine. So I take the largest one, like I said, the 5, and I start writing multiples. Just 5. Can you take 5 divided by 2 evenly? No. Can you do the next one? 10. Can you take 10 divided by 2 evenly? Yes. So 10 is the number part. Now I've got an end of the third and an end of the second. You take the larger one. Is there anything else in there that I haven't touched on yet? Any other variables? No. So this is my new common denominator. So I'm going to set this up. So you have to now figure out what did we multiply this by to get this? Because then I need to multiply the top by the same. Do you see it? That's right, just a 2. The end of the third is the same. So I just had to multiply this by 2 and I'll get the 10 and I'll be good. Well, you have to do the same at the top. So 2n times 2 is 4n. And that's how we're going to work with fractions with these polynomials. Now, how about this one? 2n to the second. What do I have to multiply that by? Well, to get the number part, we need to multiply it by a 5. And to get the letter part, what do we have to do? Got 2 of them, but I need another one. I need a third one. So we are going to do the same on the top. And what do we get? Well, you multiply the numbers, you get 20. N times n is n squared. Now, I don't want to start simplifying. Some of you might see this and think, oh, that's 2 over. Yeah, we can simplify, but we're going to end up back here. I'm trying to put these together. So we're going to go ahead now. Common denominator is there. I can put that on the bottom. And is there anything on the top I can add together? I got an n term here and an n squared term here. So I cannot put those together. So I'll write them in descending order. And now I need to factor. Because I can see that there is a couple things I can take out here, aren't there? What's a common factor of 20 and 4? That's right, 4. And what's a common factor of n squared and n? N, very good. So when I divide 20 by 4, I get 5. And if I take one of these n's out, I have 1 left inside. Oh, I took the whole 4n out. So do I put 0? No, you never put 0. You put 1. Because then when you multiply it back out, you would get the 4n back. All right, so anything else? Now that I've divided that, I can look to see if anything cancels. Now that I've got this. I know I don't have a 5n plus 1, so that's going to be staying. But we got these. And there's no adding in this one, so these can be split up. Divide this by 2, divide this by 2. Oh, I've got some n's. Here's 1n and here's 3. So I am going to be left with 2 of them in the bottom, right? I've got 2 more in the bottom. So let me rewrite that now. I've got 2 times 5n plus 1 all over 5n to the second. You have to be very careful here not to miss parts. And lastly, we will just get rid of the parentheses to have our final answer. Woofda! Yeah, all right. Uh-oh. You guys see the problem? Yeah. We like the variable first. So let's do that. Take out a -1. You guys know that now. hopefully. I've done the last 3 videos right in a row, so I know I've said it about 10 times. All right. So let's look at these two. If I need a common denominator, what am I going to make it? The only thing missing here is the -1. Is that correct? So if I multiply that by a -1, I have to multiply the top by a -1 as well, wouldn't I? But then I would have the common denominator. So I'm going to be left with 2, and this 5 times the -1 is a -5, and then it's minus a negative, so it's plus 5, all over I'm going to multiply this out again to get rid of it. All done. All right, last one. Roland needs to take supplies by canoe to some friends camping 2 miles upriver and then return to his own campsite. Roland's average paddling rate is about twice the speed of the river's current. Write and simplify an expression for how long it will take Roland to canoe round trip. So pause your video and reread that again. Okay, and I also wanted to mention too that St. Agnes is you're on a different schedule, so you can stop the video now if you wanted. This is quite a complicated problem, isn't it? I mean, we're going to go through it, but this is cool. I mean, first of all, if we're trying to find a distance, who remembers the formula when we talk about speed and time and distance? Okay, well, we got to remember that first of all. Distance equals rate times time. Okay, so let's see what are those things we have, because it says write and simplify an expression for how long it will take. Well, do we know the distance? Well, 2 miles and then 2 miles. Okay, so I'm going to put 2 miles both directions. And then rate. Well, there's 2 rates, isn't there? So we've got the rate of current, and we'll call that x. But then we also have the paddling rate. And what did they say that was? Roland's average paddling rate is about twice the speed of the river. So that's about 2x. Okay, so let's make a little chart. I think that will help. Okay, let's just say direction, because it's different whether you're going up or down, isn't it? Stream. Okay, so if the direction is upstream and downstream, and the distance is the same, right? So it's 2 and 2. But the rates are going to be a little bit different. So the rates, let's look at them. If we're going against the current, how would we figure out the rate? Well, it's going to be, I mean, he's trying to paddle this fast, but you're going to take away the rate of the current because you're going against it. So when you're against the current, your rate is only x. But when you're going with the current, then you have that additional support and you have 3x. Okay, so let's see. When you're going upstream, you're going against the current, so that would be x. When you're going downstream, it's with the current, so it would be 3x. And the time. Well, the time up here, if you were to solve for time, t is equal to d over r. So the time in here is d over r, so it'd be 2 over x. And the time here is d over r, so it'd be 2 over 3x. Not thinking I'll be giving you a problem like this on the test, although I should, just for the fun of it. So let's see. So how long will it take? Well, we got to add our times together to get how long it's going to take. So 2 over x plus 2 over 3x. And now you've learned how to work with different denominators. You need to get a common denominator. So I'm going to have to multiply this by 3 and this by 3 so that I can get 3x on the bottom. And then I'm going to have 6 plus 2 is 8. There you go. Now, if the speed of the river's current is 2.5 miles an hour, how long will it take to make the round trip? Okay, so see, they gave you this now. They gave you the 2.5. So it'd be 8 divided by 3 times 2.5. What is that? Okay, 8 divided by parenthesis 3 times 2.5 parenthesis equals. So I get 106 repeating. And what is that? 106 what? What are we talking about here? Do we have any idea? Minutes, hours? Where is that information? Oh, duh, it's right there. Hello, hours. Okay. So it's 1.06 hours. And there you go. Woofda. All right. Well, that was a load of fun. You guys are set to have a great day now, aren't you? All right. Take care. Bye.